All right, now it's time to get into the metric system. We're on page 17 in the workbook. So we're going to spend the next few pages getting into the metric system. And I don't care what QAnon says or Sean Hannity says, the metric system is not some conspiracy to turn us into a socialist new world order. There are far more practical reasons why we use the metric system. And chief among that is this: it can be applied directly to scientific notation. That's the beauty of it. It uses a system of units and prefixes. Units relate to specific measures. What you got? And by that I mean liters, meters, or hootigeters. What you got? Prefixes are specific quantities. How many you've got? Prefixes are, here's the important piece, prefixes are mathematically equivalent with powers of 10. They're interchangeable. All right, so that's the basic idea. Now, let's go through a few of these. So, examples of units. I can talk about a meter, which is a unit of length. I can talk about a liter, which is a unit of volume. And I can use a gram, which is a unit of mass. All right. Examples of prefixes. Centi. Centi is 0.01, or more importantly, 10 to the negative 2. Milli is 0.001, or 10 to the negative 3. Kilo is 1,000. 10 to the third. All right, so as a result then, at the bottom of the page I have 8.5 centimeters, or I can say 8.5 times 10 to the negative 2 meters. I could have 500 milliliters, or I can have 500 times 10 to the negative 3 liters. I can have 6.75 kilograms, or I can have 6.75 times 10 to the third grams. The bottom line, any prefix can be replaced or substituted with a power of 10. Okay, any prefix can be replaced or substituted with a power of 10. Now, probably in your travels through a high school physical science course or a math course, you encountered the prefixes like deci and hecto and nano and all of that. Okay, there's a whole list of them. Okay, the good news is you don't need to know those. But let's turn to page 18, and there is the bad news. The bad news is this. There are 6 of these prefixes that I want you to know. Make them part of your vocabulary. All right, so we'll get set up. So we'll start with giga, or if you want to be fussy about it, giga. Standard notation, that's 1 billion, 1 with 9 zeros. No fraction involved here. Power of 10, 10 to the 9th. Next is mega. Just like megabucks, 1 million. Again, no fraction, 10 to the 6th. Kilo, that's 1,000. No fraction involved, 10 to the 3rd. Centi. Standard notation, 0.01. Fraction, that's 1/100th. 10 to the -2. Milli. Point 001. 1/1000th. 10 to the -3. And finally, micro. Point 0.00001. 5 zeros and a 1. 1 over 1 million. 10 to the -6. All right, these are the ones that I do want you to make part of your vocabulary. Do know these. If you have to stop and look them up every time you encounter them, it's going to really suck. So yeah, do learn these. And these are the ones that will get you through this course. So this is what I mentioned earlier, is that learning the language is what's going to take up time. So here you are. Here's the language that you need to learn. All right, so that is your assignment, is to learn this language, make it part of your DNA. Next page, page 19, is a sheet for you to practice. We're all adults here, so I'm confident that you will actually practice these and then go back and check on page 18 to see if you got them right. Page 20. Okay, well, before we get to page 20, actually, we're going to go to page 19A. Okay, so I got a little out of sequence there. Okay, so before page 20, we have page 19A. We're going to do a little practice with these. So we're on page 19A, not page 20. All right, so let's practice with a few of these conversions. I'll demonstrate the first one, and then I'm going to ask you to hit pause and try the next 5 that come after that. So the first one will go like this. We're going to convert them. We're going to convert these measures into scientific notation and then to standard notation. Now, believe it or don't, it's actually simpler to convert them into scientific notation first, and then convert them into standard notation. Let me show you what I mean. Here's our first one, 8.97 kilograms. So first I will convert that into scientific notation. 8.97. This kilo, I'm going to replace that with 10 to the 3rd grams. See how easy that is? All right. Now, I'm going to convert this into standard notation. And the thing to keep in mind always, standard notation, this is a good cheater. Standard notation is 10 to the 0. Remember, 10 to the 0 equals 1. So, from 10 to the third to 10 to the 0, don't forget this. So, from 10 to the third to 10 to the 0, my exponent is going down. That means that my decimal point is going to move to the right, and so the answer becomes 8,970 grams. So I'm going to ask you to hit pause and try the next 5, and so I'll just pause here briefly, and now I'm going to assume that you have hit pause, and I'm going to continue on with the remainder. All right, so 6.5 centimeters. 6.5 centimeters. All right, so I'm going to convert it to scientific notation first. 6.5 times 10 to the negative 2 meters. All right, now I'll go to standard notation. Standard notation is 10 to the 0. So from a negative 2 to a 0, my exponent is moving up. So that means that my decimal will move to the left. All right, here we go. Next example. 7.5 gigavolts, Marty. You knew that one was coming. All right, great Scott. 7.5 gigavolts. All right, just scientific notation. 7.5 times 10 to the 9th volts. Now I'm going to go to standard notation, 10 to the 0, 9 to a 0. My exponent is going down. My decimal goes to the right. $9,700,000,000 volts. 4.7 microfarads. Not ferrets, farads. What's a farad? It's an electrical unit. All right, so 4.7 times 10 to the negative 6 farads. All right, now I'm going to go to 10 to the 0 for standard notation. From negative 6 to a 0, it's going up. So my decimal moves to the left. .0000047 farads. 5 zeros and then the number. 6.7 megawatts. Yeah, I see that that's a comma there. It's supposed to be a point. All right, 6.7 megawatts. .7 times 10 to the negative 6 watts. Oh, I'm sorry. Positive 6 watts. 6.7 times 10 to the 6 watts. All right, I'm going to go to standard notation. From a 6 to a 0, my exponent moves down. Means that my decimal point moves to the right. So 6,700,000 watts. Okay. Finally, 9.87 milliliters. All right, so that will be 9.87 times 10 to the negative 3 liters. Going to standard notation, 10 to the 0, negative 3 to a 0. My exponent goes up, decimal point goes left, 3 places, 0.00987 liters. The next section on this page is more for a practical approach. How would we use this on a practical level? So here are some examples. I could say 5,483 grams, or I could do this. 5.483 kilograms. I could say 0.0268 meters, or I might say 2.68 times, or rather, centi. Or if I was doing machining or automotive, I might say 26.8 millimeters. Here we have 0.0000056 farads. On a practical level, I would say 5.6 microfarads. I could say 0.0045 liters, or 4.5 milliliters. I could say 4,300,000 watts, or 4.3 megawatts. All right. Get familiar with this. All right. Now we go to page 20, and I'm going to address something that has been a perennial bugaboo for a lot of students, not only in physics but also in chemistry and other disciplines that require dealing with prefixes and scientific notation. And I'll be candid with you. I've looked through any number of textbooks to find a clear-cut way to present this idea, and they just don't exist. So through trial and error, this is what I've come up with. And students have reported back to me that this has actually been quite useful to them. So here we have 3.567 times 10 to the 5th gigavolts. We're going to convert that into millivolts. I'm going to show you how to do that conversion twice. The first time, I'm going to explain everything I'm doing. And then I'm going to do the same problem again with minimum explanation so you can see just how fast this really goes. All right, so here we go. We got 3.567 times 10 to the 5th gigavolts. Now, I'm going to set up my conversion like an equation. That's going to equal 3.567 times 10 to the I don't know millivolts. And that's the trick. That's one of the tricks to surviving physics. You front load your problems with no-brainer stuff. Stuff that clearly articulates what the problem is. And here it is. This is my problem. I got this amount of gigavolts. I want to make it this amount of millivolts, but I don't know what the answer is. And that pretty much states it. So, taking a look at this, remember this from your high school algebra course. You have like terms on both sides of this equation. Another way to look at it is this. Is that 3.567 going to change? And the answer is obviously no, it's not. So that's not really in play here. What about my unit, volts? Is that going to change? And again, no, it's not. So now what I've got left are powers of 10 and prefixes. And remember, prefixes are equivalent to powers of 10. So let's see what we got left here. All that's really left is this. 10 to the 5th, and giga, that's 10 to the 9th. And they're being multiplied. Equals 10 to the I don't know times 10 to the -3. Now again, look at this. We have multiplication problems involving exponents. Are the bases going to change? And the answer is no, they're not. So I'm going to get rid of the bases. And what do we do with exponents when we're multiplying? Well, we add them. So here's what the problem really comes down to. That's a pretty simple algebra problem. So I'm going to add a positive 3 to both sides. Five plus 9 is 14, plus 3 is 17, equals, these cancel out, x. So what's my answer? 10 to the 17th power. Now, I'm going to do the same problem again, and again, like I say, with minimal explanation. And watch how fast this goes. Now, I'm still going to set it up exactly the same way. I'm still going to lay it out in detail. So my original problem is 3.567 times 10 to the 5th gigavolts. Equals 3.567 times 10 to the x millivolts. Okay, so now I know all I'm dealing with is prefixes and exponents, so I'm going to go 5 plus 9 equals x plus -3, add positive 3 to both sides. Look how fast that goes. You won't find that anywhere else, unfortunately. But you see how quick that is? Get used to that one, and that's going to save you a lot of grief. All right. Page 21 is a practice sheet for you to do. And what I'm going to do is I'm going to stop this video here, and put the solutions up on a separate video to follow, because I want you to try it first and then watch my solutions. So I'll see you on the other side.